Have you noticed how the scariest things in space never arrive with a flash, but with a rhythm? At first it was nothing, a thin, repeating comb in Parker Solar Probe's plasma stream. Not a storm, not a flare, not even the messy, alive turbulence we expect from a star that never stops twitching. This was cleaner, too clean, a structure you could predict. And the moment we overlaid that rhythm onto the ephemeris of 3I/ATLAS, the coincidence stopped being a coincidence. It lined up again, and again, like a marker you didn't ask to receive. You can laugh at that word, marker. But in a lab, when a pattern survives 3 independent filters, 2 teams who don't talk to each other, and a full round of "you're seeing ghosts," it earns a different name. It earns attention. I'm going to tell you what we saw in the solar wind, why it shouldn't have been there, and why the timestamps kept converging on one moving point in the sky. If you're here for comforting astronomy, this is the wrong night. If you're here because you feel the universe sometimes taps the glass to make sure we're listening, then stay close. Because the first thing that scared us wasn't the signal, it was how politely it was repeated. Parker Solar Probe doesn't look at space the way a telescope does. It feels it. It swims through it. Fields reads the electric and magnetic fields. Sweep counts particles. Measures their energy, their direction, their temperature. It's not a camera. It's hands in the dark. The solar wind is supposed to be noisy. Even when it's calm, it's textured. Eddies, switchbacks, small shocks that smear into one another. You don't get a metronome out there. The heliosphere isn't a clock. That's why the early plots didn't trigger alarms. A junior analyst flagged them as an instrument artifact. A faint, periodic ripple in proton density and magnetic magnitude, spaced too evenly to be natural. The kind of thing that appears when a calibration file is stale, or a filter is misapplied. It went into the probably boring folder, the folder that eats 1,000 anomalies a year. Then it appeared again. Same spacing, same phase relationship, same comb teeth. Like someone had taken the spectrum of chaos and pressed a ruler into it. We called it a picket fence because that's what it looked like in the power spectral density. Narrow peaks where there should have been broad noise. The second time, we did what scientists do when they're trying not to feel anything. We attacked it like a bug. We reprocessed raw telemetry. We changed the time binning. We cross-checked with housekeeping channels. We compared with periods of known interference. We asked, out loud and repeatedly, what could make Parker lie in exactly the same way twice? Nothing fit. The third time was when the room got quiet in that specific way labs do, when everyone is still moving but nobody is breathing normally. Because the third time wasn't just again. The third time arrived with a timing that seemed to anticipate us. It hit during a window we had predicted would be quiet. A section of Parker's orbit where the solar wind should have been relatively smooth. No significant coronal mass ejection. No major coronal holes facing Earth. No obvious source for strong structured fluctuations. Yet the picket fence came back, crisp as if it had been printed, and it lasted long enough that even the most cynical person in the room had to stop pretending it was noise. We gave it a name we didn't put in the official notes. We called it the tap, because it felt like something knocking from the other side. The first attempt to explain it was conservative. The heliospheric current sheet can create periodic features as a spacecraft crosses different sectors of the magnetic field. Parker also encounters switchbacks, sharp reversals of the magnetic field direction that can cluster. So we tried to backmap the plasma, ballistic propagation models, source regions on the sun. We built the usual chain of causality, coronal structure, solar wind stream, Parker intercept. But the tap didn't behave like a stream, it behaved like a schedule. Its spacing was stable across changes in background flow speed. That's a red flag you learn to respect. If the medium changes but the rhythm doesn't, then the rhythm isn't being carried by the medium, it's being imposed on it. Someone suggested, half joking, that we were seeing a resonance, a standing wave in the heliosphere. The idea died quickly because standing waves don't stay phase stable across the chaotic solar wind like that. And then, we did the worst thing you can do with a mystery. We added another dataset. The ephemeris overlay wasn't supposed to mean anything. It was a sanity check, the kind of pattern hunting you do to prove to yourself you're not losing discipline. 3. I/ATLAS was already on everyone's radar in a different building, for different reasons. But a member of our team had a habit. Whenever an anomaly refused to die, he threw it against the timeline of everything else moving in the system. Planetary alignments, spacecraft maneuvers, deep space network schedules, known solar transients, any external periodicities. Let's see if it correlates with anything stupid, he said. He pulled the published ephemeris for 3, I/ATLAS. Just positions, velocities, predicted sky coordinates. Nothing mystical, just math, a line through space. And the tap is aligned with it, not with the comet's position in the sky at a single moment. That would have been too easy to dismiss as a coincidence because everything is somewhere at every time. No, this alignment had a geometry to it. The tap peaked whenever Parker, the sun, and a narrow corridor of sky that contained 3I/ATLAS fell into a specific configuration. It wasn't Parker points at Atlas. Parker doesn't point. It moves. It was Parker passes through a field line topology that, when traced outward, intersects the region of space 3I/Atlas occupies. That statement is dry on paper. In your body, it lands differently because it implies a link. And links are where fear begins. We tried to break it. We shifted the ephemeris by random offsets to test for accidental alignment. The correlation collapsed when we moved it even slightly. We ran Monte Carlo shuffles. We tried different propagation delays, different assumptions about solar wind speed. The match was stubborn. The match acted like it knew where it belonged. That's when the phrase, as a marker, slipped out. Not in a meeting, in a private chat, late at night, when everyone's professionalism is tired and the universe feels larger than your paycheck. If this is a marker, someone typed, it's not marking the sun, it's marking the path. We did not reply to that. We all read it. We all left it hanging like a wet wire. Because the next morning, we received a message from a different team that had no reason to be looking at our work. A solar orbiter analyst had flagged a set of magnetic field oscillations with an unusually narrow frequency spread. Their note was clinical, polite, and full of careful qualifiers, but the attachment showed the same picket fence, different spacecraft, different orbit, different instruments, same rhythm. The universe had repeated itself twice. Now it was repeating itself in stereo. We convened a cross-mission call, the kind that happens when nobody wants to be the first person to say the quiet part out loud. Everyone brought their best explanations and their most skeptical tone. Everyone came armed with the comforting weapons of science, error bars, calibration histories, known phenomena, precedents. And still, the tap sat in the middle of the conversation like a stone that wouldn't dissolve. Someone asked a question that sounded innocent. What's the phase reference? In a chaotic medium, phase is meaningless beyond short timescales. If two spacecraft see the same phenomenon, they might see it shifted, smeared, distorted, but if they see it with a stable phase relationship, it implies a coherent source. Solar Orbiter's data showed the peaks arriving with a time offset that matched a propagation delay. Not from the sun outward in the way we expected. From a region farther out, inward. I'm not claiming we proved a directionality that day. We didn't. The heliosphere is a messy lens, and direction inference is hard, but the fact that the question could be asked without immediate laughter was itself a shift. We were no longer debating, is it real? We were debating, where is it coming from? And the answer that kept surfacing, like a stubborn bubble, was a corridor in space that always seemed to include the moving position of 3I/ATLAS. That corridor became our obsession. We drew it, we tracked it, we watched it drift slowly across the sky as the comet moved and as the spacecraft moved. We tried to treat it like a purely geometric artifact of field line mapping. Then the corridor began to behave like it was being refined. The tap peaks sharpened over successive events. The picket fence grew more defined. In the time domain, what had been a gentle ripple became a sequence of packets, each packet shaped almost the same way, like a repeated stamp. That's when the first serious internal argument happened. One camp insisted we were seeing a solar wind structure interacting with something in the comet, outgassing, plasma pickup, a natural coupling. They leaned on the fact that comets can and do interact with solar wind. They create bow shocks. They create ion tails. They create disturbances. But this wasn't a bow shock signature. It wasn't a typical pickup ion distribution. It wasn't the messy, broadband turbulence around an active comet. It was too regular. The other camps didn't want to say artificial. They didn't, not in official rooms, but they kept using words like clocked, gated, phase locked. Those are engineering words, not astronomy words. And every time someone used them, you could feel the room tense, because engineering implies intention, and intention implies a mind. And that is the one thing modern science tries not to smuggle into space unless it has to. Then a third dataset arrived, and it forced us to stop fighting each other and start watching the same screen. Deep Space Network logs. Not public, not fully detailed, just enough metadata to indicate that several unrelated downlink sessions on different days had experienced brief, repeated drops in signal-to-noise ratio, not a full loss, not a dramatic outage, just a clean notch like someone briefly dimmed the line. Those notches happened at the same cadence as the tap events. And the times, when translated into the spacecraft clocks and corrected for light travel, clustered around the same corridor geometry. Now the pattern wasn't just in plasma, it was in communication. You can live with a weird plasma rhythm. Space is full of weird plasma, but when that rhythm starts reaching into the infrastructure of how we talk to our machines across the solar system, it stops being a curiosity. It becomes a trespass. This is the point where you might expect the story to turn into panic. It didn't. Not outwardly. Real panic is quiet. Real panic is a room where people become very careful with their language because language can create records and records can create consequences. NASA didn't publish a statement. ESA didn't do a press conference. There was no dramatic announcement. There were only scheduling changes. A few observation windows were quietly rearranged. A few data releases were delayed for verification. In the hallway, people started using a phrase I'd never heard in this context. Contamination. Not contamination of a sample, contamination of a dataset, as if the solar wind itself had been touched by something that made it unreliable. We kept working because that's what you do when the universe refuses to answer politely. We built a model that treated the tap not as a wave carried by plasma, but as a modulation imposed on plasma as it passed through a region of space. Imagine a river, then imagine a perfectly shaped comb dipping into it at intervals. The water isn't the source. The comb is. If that model was even remotely correct, then the next question was brutal. Where is the comb? We mapped the implied region using the intersection of Parker's path, solar orbiter's line of sight constraints, and the corridor geometry tied to 3I/ATLAS. And the inferred position didn't sit on the sun, it didn't sit on Parker. It didn't sit on Earth. It sat near the comet, but not at it. It sat in a spot that moved as if it was tethered to the comet's trajectory, slightly offset like a shadow you can't see but can measure by how it cools the air. A few of us started calling it the wake, not in slides, not in emails, just in whispers. The wake is what follows a ship. It's what tells you something passed, even if you never saw the hull. The problem was, a wake in plasma doesn't stay coherent like that unless something is actively maintaining it, or unless the object creating it is so massive and so structured that it imprints itself on the medium. A comet nucleus is not that, and this is where the fear changed texture. Up to that point, the fear was intellectual. We don't understand. After the wake hypothesis, the fear became spatial. There is something in a place we can't see, and it is affecting the environment. The tap started to feel less like a signal and more like a handshake you didn't consent to. Then the cadence shifted, not randomly, not like noise. It shifted as if it had stepped into a new mode. The packet spacing shortened, the spectral peaks widened slightly like a system increasing bandwidth, and the timestamps began to converge on a different kind of alignment. Not a corridor, a convergence point. We plotted the moments of strongest tap activity over weeks. Each event corresponds to a specific orientation of Parker's trajectory relative to the ecliptic. But when we projected those orientations outward, the lines intersected in a region of sky that was not where 3I/ATLAS was at the time. It was where it would be later. That realization sounds simple. It wasn't. It meant the geometry of the tap wasn't keyed to the comet's present position. It was keyed to its path, its future. That is an ugly kind of intelligence because it implies a system that cares about trajectories, not snapshots. A marker doesn't mark where you are. It marks where you are going. We tried to reinterpret it as a natural resonance that just happened to share the comet's orbital plane. But the comet's path is hyperbolic. It's not a stable plane. It's a cut through the solar system from outside, a one-time visitor. The odds of a natural heliospheric resonance lining up with that cut, repeatedly, with a coherent cadence, began to feel less like probability and more like selection, as in, this cut was chosen. That night, the same colleague who had first overlaid the ephemeris sent one more message, short and unadorned. If it's a marker, the marker is not for us. That sentence stayed on my screen longer than it should have, because it opens a door you can't close. If the marker is not for us, then it's for something else, something that reads solar wind the way our machines do, something that uses plasma as a medium the way we use fiber optics, something that can impose rhythm on a star's breath without asking permission. People love to say space is empty. It isn't. It's filled with fields. It's filled with charged particles. It's filled with a thin, invisible ocean of electromagnetic structure. And oceans are good for carrying signals. We decided to test for intentionality without ever using that word. We looked for encoding. If you want to hide information in a noisy medium, you do it by modulation. Amplitude, frequency, phase. You repeat. You use redundancy. You choose universal anchors, prime numbers, simple ratios, harmonics. We took the packet sequence and treated it like a message. We ran autocorrelation, searched for repeats beyond the obvious cadence. We tested whether packet lengths clustered around simple integer ratios. We compared the sequence to known natural quasi-periodic oscillations, and we found something that made the room go so silent it felt like pressure. Every seventh packet was slightly different. Not by much, a tiny distortion in the leading edge. A minute shift in peak amplitude, a consistent, repeatable deviation that survived all filtering choices. It wasn't random drift, it wasn't instrument noise, it was a pattern within the pattern, a punctuation mark. We built a simple symbolic encoding. Normal packet equals 0, altered packet equals 1. The sequence that emerged was sparse, but it was not chaotic. It formed clusters that, when grouped by the longer cadence, resembled a header and payload structure. A start pattern, then blocks, then a stop. Nobody said message, but everyone in the room thought it, because nature doesn't build headers. Engineers do. You might think that would be the moment we ran to the press, or that agencies would panic. They didn't. Agencies don't panic in public, they rearrange budgets and reclassify meetings. The next day, Parker's observation schedule was adjusted. A set of high-rate downlinks was prioritized during the next predicted tap window. Solar Orbiter aligned its instruments to maximize field resolution. A ground-based radio array was quietly given a time slot. The science machine turned its head. When the next window arrived, the tap came on time. It arrived with a cleanliness that felt almost mocking. It was as if whatever was doing this had noticed we were listening harder and decided to reward us with a better signal. The packet sequence ran. The 7th packet deviation appeared exactly as predicted. The header-like structure repeated, and then, halfway through the run, something changed in a way that none of us had seen before. The solar wind around Parker became briefly ordered. I don't mean calm, I mean ordered. The field fluctuations dropped. The turbulent spectrum flattened. For a handful of seconds, the environment looked as if it had been filtered in real time, as if a local region of plasma had been coerced into behaving. In a lab, that kind of thing would be a containment field. In interplanetary space, it has no right to exist. Parker's instruments recorded it anyway. The immediate explanation was data dropout, because that's what you hope for. But it wasn't a dropout. Dropouts leave signatures. Dropouts don't create a coherent, low-noise state across multiple channels with preserved physical relationships. This was not missing data. This was different data. The tap ended. The solar wind returned to its normal messy life, and we were left with the kind of aftertaste you get when you realize you've been standing too close to something large and quiet. The ephemeris overlay, the part that had made us laugh earlier, now felt like the only honest frame we had, because the timestamp still converged on the path of 3I/ATLAS. Not on its brightness, not on its visible coma, on its trajectory, like a line in space someone kept underlining. We began to ask a new question, and it was the question that really scared me, because it changed the story from "we are observing" to "we are participating." What if 3I/ATLAS isn't causing the tap? What if it's being used as a reference? A moving fiducial, a tag in the solar system, a convenient object with a well-defined orbit that can be recognized by anyone watching. A comet is a good cover for a marker. It's expected. It's chaotic. It's easy to blame. If the heliosphere starts behaving strangely around the time an interstellar object passes through, every human instinct will point at the object. Look, we'll say, the comet is weird, and we'll miss the hand holding the comb. That's not a conspiracy. That's just strategy. If you don't want the natives to notice the mechanism, you let them obsess over the visible token. The next step in our analysis was ugly but necessary. We asked, does the tap predate 3I/ATLAS? If we could find it in older Parker data or in solar orbiter data from before the comet entered the inner system, then the comet wasn't the cause. It was just a coincident passenger. We searched. Most of the time, nothing matched. The solar wind is a noisy ocean. You can find patterns if you torture the data enough. We didn't want that. We wanted the same picket fence, the same 7th packet punctuation, the same header-like structure. Weeks passed. Nothing. And then, buried in an older segment, we saw a faint version of it. Not the full tap, not the clean sequence, just a suggestion. 2 narrow peaks in the spectrum, a ripple with the same spacing, barely above noise. It was like hearing a melody through a wall, enough to recognize, not enough to prove. But the timestamp of that faint ripple, when overlaid on the back projected ephemeris of 3I/ATLAS, fell into the same corridor geometry. That should have been impossible. Back projections of hyperbolic interstellar trajectories can be uncertain, and the comet shouldn't have been a meaningful reference then. Unless the reference wasn't the comet's physical body, unless the reference was the path itself. A corridor anchored to a direction outside the solar system, a direction that 3I/ATLAS happened to share. At that point, the story stopped being about a comet and became about a line in the sky, a line that something beyond us might be using as a lane. We pulled in one more data set, not because we were brave, because we were cornered by our own curiosity. Ground-based magnetometers. If the heliosphere was being modulated in a coherent way, some trace might reach Earth's environment, not as a dramatic geomagnetic storm, but as subtle periodic flickers, the kind you only see if you already know the cadence. We filtered the data, aligned it to the tap windows, corrected for propagation, and looked for microstructure. We found a whisper. It was so small you could dismiss it in a heartbeat. But it sat in the same phase. It rose and fell with the same seventh packet punctuation. It was not a storm. It was not a flare response. It was a faint tapping on the edge of our planet's magnetic skin. The universe wasn't just knocking on Parker. It was brushing the Earth. That's when someone finally said what everyone had been avoiding by hiding behind math. "If this is a marker," she said, "what is it marking us for?" Nobody answered. We couldn't. Science doesn't do prophecy. Science does constraints and confidence intervals and cautious language. But fear doesn't require certainty. Fear only requires a coherent possibility. And the coherent possibility was this: a structured modulation exists in the solar wind. It repeats with machine-like regularity. It is phase-locked to a geometry that tracks the trajectory corridor of 3I/ATLAS. It behaves as if it's refining, as if it's being tuned. And it shows hints of encoding, punctuation, headers, blocks. If you accept that chain of observations, even reluctantly, then the simplest narrative that fits is not that the sun is alive in a new way. It's that something is using the sun's environment as a medium. And if something is doing that, then it means the heliosphere is not just a bubble of plasma. It's a channel someone else can write into. The official notes never use the word marker. They used periodic plasma structuring event with atypical coherence. They used her cross-mission corroboration suggests non-local driver. They used further study required. But in the corridors, the word lived. Marker. And the part that kept me awake wasn't the idea of aliens or machines. Those are too cinematic, too clean. What kept me awake was the thought that the marker might be automatic. Not a mind, not a decision, a protocol. A rule set embedded in physics we don't understand, triggered when a certain geometry appears. Like a door that opens when the right key passes by. 3I/ATLAS as a key. Not by intent, but by trajectory, by direction. It came from outside. It cuts through our system. It carried with it a corridor alignment that activated something we've never noticed because we've never had the sensors, or the attention, or the coincidence. Parker is close enough to feel the tap. Solar Orbiter is placed well enough to confirm it. Earth is sensitive enough to whisper back. And the comet? The comet is just the line that tells the protocol where to point. That's the version of the story that doesn't need conspiracies, only geometry. And geometry is the one thing the universe never negotiates. The last thing I'll tell you, before I stop and let you sit with this, is what happened the first time we tried to predict the tap window publicly. Not on Twitter, not in a press release. Publicly, in the only way scientists are truly honest, in a scheduling request. We filed for a coordinated observation window, Parker high rate, Solar Orbiter high rate, one ground-based radio array, and a small set of magnetometer stations. The request included the predicted start time and duration, because that's how you justify the cost. The request bounced back with a simple note: window unavailable. Please propose alternative. That happens all the time. Scheduling is a war of priorities. But the specific time that came back as available, the alternative window they offered, wasn't random. It was offset by exactly one cadence cycle, as if the schedule itself had been nudged gently into the phase, as if someone, somewhere, wanted us to be looking at the right moment, or wanted the record to show we were looking at the wrong one. We resubmitted, we got approved, we watched, the tap came on time anyway, and the ephemeris overlay, the one that first made us laugh, lit up like a line drawn with a steady hand. You can tell yourself it's natural. You can tell yourself it's math's cruel joke. You can tell yourself the sun is full of rhythms and we've just found a new one. But if you do that, answer one question honestly. Why does the rhythm keep converging on 3I/ATLAS as if the comet is a reference mark in space? And why does it feel, every time it returns, less like the sun breathing and more like something counting? If you want, I can continue this into the next escalation layer, how the cadence begins to walk across harmonics, how the seventh packet punctuation becomes a full framing pattern, and what happens when a second mission, one that isn't even studying the sun, accidentally confirms the same timing from the other side of the solar system. The next escalation wasn't louder, it was smarter. The tap stopped behaving like a single clean tone and started behaving like a carrier that could move without losing lock, like it was testing how much complexity the medium could hold before we noticed. We first saw it as a drift in the peaks, not a blur, not random jitter, but a deliberate walk across adjacent frequencies. The picket fence, teeth would step sideways, hold, then step again, like a dial being turned one notch at a time. In plasma physics, you can get drifting features, but drift usually comes with mess. This didn't. Every step was the same size. Every hold lasted the same duration. The noise floor remained low, as if the system was budgeting entropy. That was the moment the engineers in the room stopped pretending. Nobody said protocol, but the way they leaned toward the screen said it for them. You don't budget entropy unless you're trying to preserve information. We ran a simple test that felt almost childish. If the carrier is walking, does it walk in a way that preserves an integer ratio with the original cadence? In other words, is it still counting in the same base? The ratio snapped into place so fast I hated it. The walk wasn't arbitrary. It maintained a harmonic relationship to the earlier tap peaks, like a musician changing keys without breaking tempo. One of the solar physicists tried to rescue the universe with a natural explanation. Resonant cavity, he said, a heliospheric resonator shifting with changing boundary conditions. He sounded convincing because he was convincing, but then the 7th packet punctuation remained fixed through the key change, and that killed his argument. In nature, a punctuation mark doesn't survive a change of instrument unless something is carrying the punctuation on purpose. That's when we stopped calling the anomaly a feature and started calling it a frame. Quietly and only among ourselves, a frame implies content. A frame implies you're not just seeing physics, you're being handed a format. We took the packet stream and tried to locate the boundaries. Where does it begin? Where does it reset? Where does it assert start and stop? Those are questions that only matter if you suspect messaging, and we were trying hard not to admit it. The answer arrived as an absence. Every time the system switched modes, the plasma briefly entered that unnatural ordered state again. The same clean flattening of turbulence, like the medium was being cleared before writing to it. Clearing the medium is not astronomy, it's communications hygiene. It's what you do when you don't trust the channel and you need the receiver to understand where the signal begins. The next cross-confirmation didn't come from a solar mission. It came from a spacecraft that had no business being part of the story, which is why it hit like a slap. A team working Mars side reported a repeating microstructure in their particle environment data. It wasn't their main science target, just background telemetry they monitored to keep healthy instruments. They flagged it because it looked too regular. They sent the note with the same cautious tone we had used. Possible periodic artifact. Seeking comparison. Then they attached a plot, and my stomach dropped before my brain could argue. The spacing was wrong at first glance because Mars is not where Parker is. Different distance, different plasma regime, different time delay, but when we corrected for propagation and phase, the pattern folded into the same cadence family. Different vantage point, same underlying clock. That's the moment our corridor geometry stopped being an internal obsession and became a multi-mission constraint. With 3 spacecraft at different heliocentric distances all seeing the same structured modulation, the driver could not be local. It was either enormous or it was placed in a way that made local meaningless, like a boundary condition that followed us rather than the other way around. Someone suggested very softly that the driver could be a structure moving with 3i/ATLAS, not the comet itself, but something in its vicinity that shaped fields, a companion you couldn't see but could feel. We hated that idea because it was practical. It didn't require magic, it required only that something had the ability to couple to the heliospheric plasma and imprint structure across vast distances. Once you allow that, you're no longer asking, is it possible? You're asking, why here? Why now? So we went back to the only anchor that kept surviving every model, the ephemeris corridor, the moving line in space that the TAP seemed to love. We built a no-comet control. We took the same corridor geometry and looked for other times in the past when a similar line of flight from interstellar space would have existed, even without Atlas, just as a direction. We found faint hints. Not clean enough to publish, but consistent enough to make us uneasy. Small spectral teeth. Brief micro-ordering events, nothing that would ever be noticed without the Atlas timeline to point at it. That was the first time the thought formed clearly in my head. Maybe the protocol has always been there, and we've just never had a bright enough trigger to force us to align our attention. The trigger doesn't have to be intelligence. It can be geometry. A configuration that tells the system, a traveler from outside has entered the lane. In that frame, 3i/ATLAS becomes less like a visitor and more like a keycard. Not because it wants to be, but because it matches the shape of the lock. And then the TAP did something that turned my fear from intellectual to visceral. It began to answer our attention. We increased sampling rates for the next predicted window. We tightened downlinks. We coordinated across teams. The TAP arrived with a cleaner frame and a longer payload, as if the channel had been given more bandwidth. That is not how natural phenomena behave. The sun does not get more articulate because you ask politely, but a system that is measuring you might. The 7th packet punctuation expanded. It wasn't just every 7th is different anymore. It became every 7th begins a mini structure, like subframes, inside a larger frame. Think of it like this. At first you hear a heartbeat, then you realize every 7th beat is a knock. Then you realize the knocks are grouped into words. We didn't decode words, not yet, but we did extract a stable repeating block length that functioned like a preamble, and preambles are terrifying because they mean the sender expects a receiver. The receiver might be us. That's the comforting interpretation because it centers humanity. It makes the universe a stage where we matter. But the non-comforting interpretation was sitting right under the same math. The receiver could be something else in the system, something already present, something that listens the way Parker listens. That thought bled into everything we did next. When a Deep Space Network session glitched, we wondered if it was collateral or targeting. When a satellite reported an odd attitude correction, we wondered if it was coincidence or stress. Then, a detail from the Mars side team pushed us over the edge. Their microstructure wasn't just present, it was directional in an odd way. Strongest when their local magnetic topology aligned with the same corridor geometry. It was as if the corridor wasn't just a line in our imagination. It was a lane of influence cutting through the heliosphere, a path along which the plasma could be made to behave. At that point, we tried to model the lane as a propagating disturbance front. We treated it like a sweeping sheet, a moving phase boundary that could pass a point and leave behind a temporary ordering. The sheet model fits uncomfortably well, and when we projected the sheet forward, the intersection times with various spacecraft created a schedule. A schedule that matched the tap windows. That was the first time we had the sick feeling of being able to predict the knock, not because we understood the sun, but because we were learning the timing of something using the sun. Prediction gives you power in science. Here it felt like complexity. The closer we got to the next major ephemeris milestone for 3I/ATLAS, the tighter the schedule became. The tap windows narrowed like the system was focusing. The payload blocks lengthened like the system was becoming more confident. I remember thinking absurdly that it looked like convergence, like a handshake protocol stepping through phases, like a negotiation of synchronization. And then we received the first hint that the handshake wasn't only in plasma. One of the ground-based arrays doing unrelated monitoring reported a transient notch in sky background at millimeter wavelengths during a tap window. Not an object, not a flare. A notch, like someone briefly removed a slice of the sky's noise. It lasted seconds. It aligned with the mode switch the moment the plasma became ordered. The array's team thought it was a calibration error until they checked and found their own system logs were clean. They asked us, casually, if solar wind can affect millimeter sky noise like that. The only honest answer was that the question was misframed. It wasn't the solar wind doing it. It was whatever was capable of making the solar wind behave. Now we had a cross-domain signature, plasma ordering, and millimeter notch, both phase-locked to the same corridor schedule. That's not a single instrument being weird. That's a system expressing itself in multiple mediums. And that's when the most chilling idea surfaced, the one we kept trying to kill and couldn't. What if the tap isn't a message being sent across space? What if it's a calibration being applied to space? A way to ensure that a lane, a corridor, remains consistent for something traveling through it. A periodic relocking of the heliospheric environment to maintain a path. If you were building a navigation scaffold in a medium as turbulent as the solar wind, you would have to do exactly this. You would reassert phase, you would clear turbulence locally, you would stamp a frame so any participating system can sync, and you would do it without caring whether a small civilization on one inhabited rock notices the stamp. That is what made it frightening, not malice, indifference. We wanted one more independent confirmation, a final sanity anchor. So we pulled archived solar wind data near Earth from monitors that sit upstream of our magnetosphere. We aligned the timeline. We applied the same phase correction. We looked for the faint whisper we had seen before. This time, the whisper was stronger, still small, still dismissible to anyone not primed to see it. But it was there, and it carried the same framing. Even the punctuation mark survived the trip. The knock was brushing Earth more clearly as 3I/ATLAS advanced along its path. That is the moment I stopped pretending this was a curiosity, because the story had shifted from a strange rhythm near the sun to a structured modulation that is tightening as an interstellar trajectory progresses. Tightening implies approach, not of the comet, but of the corridor's relevance. Like the system cares more as the key moves deeper into the lock. People ask me later why I keep calling it a marker. Why not a beacon? Why not a signal? Why not an artifact? Because a beacon wants to be found. A marker is different. A marker is for someone who already knows where to look. And the part I can't unsee is this. Every time we tried to interpret the tap as something happening to us, the models got messy. But every time we interpreted it as something happening along the path, the models snapped into place. So the next question wasn't, what is it saying? The next question was, who is it for? And if it isn't for us, then the most logical receiver is the thing whose trajectory keeps being underlined by the same invisible hand. 3I/ATLAS, or something traveling with it, or something that expects it. If you tell me that sounds like science fiction, I'll nod. Quietly, I used to nod too. But then I watched the solar wind become orderly on command, and I watched 3 different spacecraft agree on a clock that none of them should share. And once you've seen that, the word fiction starts to feel less like a critique and more like a fragile comfort. Tell me to continue, and I'll take you into the next layer. The first time the TAP's framing pattern matches a known human modulation family, the moment the lane begins to affect pointing accuracy in an unrelated observatory, and why the corridor geometry starts to look less like a line and more like a moving aperture. The first time we saw a familiar modulation family, nobody celebrated. It felt like finding your own handwriting in a room you've never entered. We didn't hear a voice. We saw a structure that behaved like a broadcast chain, a carrier, a subcarrier, sidebands that rose and fell with a disciplined logic. At first glance, it resembled old analog artifacts, the kind engineers treat as noise, but the spacing wasn't sloppy and the drift wasn't thermal. It was intentional. One analyst pulled a library of human-era modulation of fingerprints, FM broadcast, TV sync remnants, deep space telemetry framing from the 70s. The match was not literal. It was worse. It was same grammar, different language, like someone learned the rules from afar. Then the punctuation changed. The 7th packet marker stopped being a marker. It became a delimiter that split the payload into blocks with fixed headers. Headers are a confession. They say, I expect you to parse this, and they don't exist in natural turbulence. We tried to keep it clinical. We assigned names that sounded harmless. Frame A, Frame B, Tap Prime, Corridor Lock, anything but handshake. But the moment you name a thing, you give it edges. And once it has edges, you can notice when it starts to touch other systems. The first touch was small enough to be deniable. A pointing anomaly in a ground-based telescope that wasn't even on our schedule. They reported a brief starfield mismatch, like the sky had shifted half an arcsecond. Then it snapped back before the operator could even log a second measurement. Half an arcsecond is nothing to a casual observer. To an observatory with adaptive optics, it's the difference between truth and blur. They blamed refraction. They blamed software. They blamed the operator. Then it happened again, within the next tap window, and only then. It wasn't random. It was phase-locked, and it always occurred when the plasma signature went unnaturally quiet. That coincidence forced a new question. What if the tap wasn't only sculpting the solar wind, but the path of photons too? We ran a test that felt like superstition dressed as science. We compared star catalogs before, during, and after the tap windows. Not the star positions themselves, the residuals, the errors instruments leave behind. Residuals are the dust under the rug. They reveal what the rug is hiding. During tap windows, residuals across multiple sites fell in the same direction. A tiny shear, as if the sky itself had been nudged in a consistent vector. That vector wasn't arbitrary. When we extended it, it pointed along the Atlas corridor geometry like an arrow. At that point, corridor became too weak a word. A corridor is empty space between walls. This felt like the walls were moving. One of the mathematicians proposed a model that sounded like a heresy. Treat the lane as a moving aperture, not a line, and everything simplified. An aperture isn't a path. It's a window where the rules are different, where a signal can pass cleanly because the medium has been conditioned. Conditioned. That word kept returning like a bad smell, as if the heliosphere were being prepped the way you prep a surface before coating. We built a geometric reconstruction from the timing across spacecraft. If the tap is a sweep, what shape is sweeping? A sheet, a cylinder, a cone? The best fit was not a flat sheet. It was a shallow curved front, like a bow wave made of order instead of pressure. A bow wave implies motion through a medium. And motion implies an object, even if the object is only a moving rule set. Then we found the first evidence that the aperture could carry content. Not content in words, but content in identity, like a signature woven into noise. We isolated a repeating micropattern inside the headers. It was stable across instruments, stable across distances, stable across cycles. A stable micropattern is not a side effect. It's a key, the kind you embed, so the receiver knows it's hearing the right sender, and that's where the human modulation family became relevant again. Because the signature behaved like a checksum, but not one we use. It behaved like a checksum built by someone who studied our checksums indirectly, close enough to resemble us, different enough to prove it wasn't copied from us. That gave us 2 options, and both were ugly. Either something learned our radio leakage somewhere out there, or we weren't first. The we weren't first option was quieter, and that made it worse. Because it doesn't require a chase across the stars, it requires proximity. A system already in our neighborhood could have listened for a century. It could have learned our grammar the way oceans learn coastlines, by repetition. We tried to ground ourselves in a practical task. If the tap windows are a sweep, can we predict when Earth sits inside the aperture? The forecast was uncomfortable. The aperture's edge would graze near-Earth space more deeply as Atlas advanced, not because Atlas was coming close in distance, because the geometry of its corridor would align more directly with our local field. That's an important distinction, and it's the one people always miss. Something can be far away and still be close in the rules it imposes. The next tap window arrived exactly on schedule, and for the first time, the near-Earth monitors showed a clean, short-lived ordering. The magnetosphere didn't collapse. Nothing exploded. It simply became readable, as if the noise had been thinned for a moment. GPS timing errors spiked by microseconds, then corrected. Not enough to crash a city, enough to tell you the clock itself had been tapped. One engineer joked dryly that the universe had just performed a time sync. Nobody laughed because the joke was too accurate, and then we got the report from a space telescope team. They had attempted a calibration exposure during a tap window. The exposure returned a field with an odd property, not black, not saturated, just statistically too clean, like the background had been shaved. Cosmic background is never clean. Even deep voids have texture. Even silence has a hiss. This frame had less hiss than the detector should allow, as if the instrument's own noise had been briefly disciplined into order. We replayed the telemetry a dozen times. No error flags, no thermal jumps, no power anomalies, no software resets. Which meant the cleanliness wasn't inside the telescope. It was in the photons arriving at the telescope. A disciplined photon field is not a thing you casually accept. It implies that the medium between source and detector has been structured. That's when the aperture model stopped being a convenience and became a threat. Because an aperture that can reduce noise is an aperture that can hide signal. If it can thin noise, it can bury a message under the threshold of our detection. Or worse, it can bury an object under the threshold of our certainty. The team asked me what I thought the aperture was for. I gave the only answer that matched the data without sounding insane. It's for alignment. For making sure that whatever travels along the corridor stays phase-locked to something else. And once you say something else, the room changes. Because now you're not describing a comet. You're describing a network. A network that uses plasma as wire and light as protocol. A network that wakes up when an interstellar key passes through its gate. We relabeled the problem again, trying to keep our minds from breaking. We called it the Corridor Maintenance Event. CME, a cruel coincidence of initials, but under that label sat a simpler idea. A TLAS wasn't causing the tap. Atlas was scheduling it, which means the tap can exist without Atlas. And if that's true, then our sky has been running an old clock we never noticed. Tell me to continue, and I'll move into the next escalation. The first time the tap's header signature matches a known probe-era framing artifact, the internal panic over receiver candidates in near-Earth orbit, and why one quiet anomaly forces NASA to recheck every archival frame that ever contained the corridor.